Hello everyone, welcome Karan. So now we're going to solve this question where we have been asked to calculate the standard efficiency of the diesel cycle, and we have been given the values of the initial pressure and temperature and also the compression ratio and the maximum temperature also. So let us see how we can solve this question. So if you draw the diagram for a typical diesel cycle, you have a diagram like this where process 1 to 2 is an isentropic compression. So let us just draw this is this. So yeah, 1 to 2 is nothing but isentropic compression. Isentropic compression. And 2 to 3 is a constant pressure heat addition. So this is a PV diagram. We have pressure is equal to constant, and this is a heat addition process. So heat will be added here. And 4 to 1 is a heat rejection process, and 3 to 4 is where the work will be uh, transferred from the piston to the crankshaft, and the engine will do the work. So this is the work done from the engine to the crankshaft. So this is how you can draw a typical diesel cycle diagram. So if you want to solve this question, you just need to calculate the cutoff ratio here, because if you like write the formula for the efficiency of the diesel cycle, you will get it is 1 minus 1 divided by r to the power gamma minus 1 into alpha to the power gamma minus 4 divided by gamma into alpha minus 1. So what is this alpha? It is nothing but the cutoff ratio. So we have a cutoff ratio. And cutoff ratio is nothing but the volume after combustion divided by volume before combustion. In our case, it will be V3 by V2. So we just have to calculate this V3 by V2 in like somehow, because we only need that to calculate the efficiency, because this is the compression ratio. We have been already given the compression ratio as a 15. And we know the value of gamma as a 1.4, because it is also given in the question that take gamma as a 1.4. So this is a gamma. If it is confusing, I will just write it once again. This is gamma minus 1. So if it's like you can just solve this, just you need to find the cutoff ratio. So let us see how we can find the cutoff ratio here. We have 1 to 2 as isentropic compression process. So we from the initial temperature we can calculate the final temperature. So why are we calculating the final temperature? Because we have been given the temperature at 0.3, and we know that the 2 to 3 is a constant pressure process. So from the ideal gas equation, we have PV is equal to RT. So pressure can be written as RT by V. And if it is a like constant pressure process, then we know that RT by V will also be become constant. So this is a constant pressure. So R2 T2 by V, if you apply it at process 2 to 3, then you will get something like this. And R is a constant, so it will just get cancelled. You have V3 by V2 as a T3 by T. So this is you can write for the process of 2 to 3. So we need to find the volume after combustion divided by volume before combustion. So you can just write it as T3 by T2, which is the temperature after combustion divided by temperature before combustion, because it is a constant pressure process. So and T3 is given as a 1400 Kelvin from our like diagram. And we also have, because it has been given that the maximum cycle temperature is 1400, and maximum cycle temperature will always occur after the heat addition. So we have 2 to 3 as the heat addition. So this 2 to 3 as the heat addition. So the temperature at 3 will be maximum. So we have T3 as 1400. We only need to find the T2. So we can all easily find T2 using the isentropic, like the formula, which is fuel to the power gamma is constant. So P can be always written as RT by V. We have TV to the power gamma minus 1 as constant. So T1 V1 to the power gamma minus 1 is T2 V2 to the power gamma minus 1. We have T1 into the V1 by V2 will become the compression ratio, which is 50 to the power 0.4. If you take gamma as 1/4, T2. So T2 will become, we have 17 degree as the initial temperature, which you need to convert into Kelvin. Those 273 plus 17 will become T1. We have 290. So if you should use, okay, this is 290 and the temperature at 1.1. So we have T2 as 50 to the power 0.5. 0.4, sorry, we have 2.95 into 290 as 856.71. So this will be our T2. So if you like, we have found the both the we have found the temperature at 2 and we know the temperature at 0.3. So we can already find out the cutoff ratio as 1400 divided by 856.71, which will be 1.63. So this is how you can find your cutoff ratio. We have a cutoff ratio as 1.63. So you just have now to put all the values in the equation, which is this efficiency equation, and you will get your efficiency value. So we have 1 divided by 15 to the power 0.4 into 1.63 to the power 1.4 minus 1 divided by 1.4 into 0.63. If you solve this equation, you will get a value something as 62.2% as the cycle efficiency. So this is how you can solve this question. If you know the formula, it will be very easy for you. You just have to find the cutoff ratio. And if you know the concept behind the cutoff ratio, you can easily solve this question. Thank you.